Our guest speaker today is the Executive Chairman of Metals Exploration PLC. He is also the President of FCF Minerals Corporation and Project Director for what he will talk about today, the Runruno Gold and Molybdenum Project in Northern Luzon. For those of you who do not know what molybdenum is, we'll ask our speaker to tell us. It has something to do with the steel industry, doesn't it? Some said it's the Viagra of the steel industry. It's what hardens the steel. He has over 37 years' experience in the mining industry and encompasses a wide range of management, operational, mine development, and feasibility study roles. He was managing director of Highlands Pacific Limited from 1997 to 2007, where he implemented the feasibility study on the Ramu nickel laterite project in Papua New Guinea, and subsequent sale of a majority interest in the project to a major Chinese corporation. He was also responsible for the feasibility study, development, financing, construction, and commissioning of the Kainantu gold mine, also in PNG, and the management of a pre-feasibility study on the Frida River porphyry, copper, and gold deposit, also in Papua New Guinea. He has extensive experience in the implementation of major project feasibility studies, equity raising, investor relations, debt financing, working with traditional societies, government negotiations, and all aspects of project development. He's a member of the Australasian Institute of Mining and Metallurgy and the Australian Institute of Geoscientists. Ladies and gentlemen, please put your hands together to welcome the gentleman who will speak to us on the topic called Runruno Today and the Future, Ian Holzberger.
Well, thanks very much, Leo, for the glowing introduction. I guess I need to disappoint you first up. Moly isn't the Viagra of the steel industry. It's actually an elasticizer, so it has exactly the opposite effect. And it tends to be used in line pipe. So it's actually used extensively in hydrocarbon line pipe to make it more elastic and more flexible in kind of earthquakes and various other disaster type situations. Outside of that, everyone would know moly's in Greece. It's the black crap that gets all over you when you're playing. So it's a very common use. Thanks to Kevin for creating the mining club and for the opportunity to stand up here in front of you. When he first asked me, I was pretty hopeful I could give you a discussion on the kind of rigging geometry of rowing boats on the Pasig. But that's the kind of topic that I reckon I could kind of tell a story on and get away with. But he's been pretty insistent that I talk about Ramu. So that's the topic. I'm going to have to be on my mettle. I'd say about 25% of the people in the room here have worked on the project and probably know as much about it as I do in one way or another. So it's good to be amongst peers. Let's see if we can get a coherent story. As a number of you will be aware, Runruno's been around for a while. It's like most good projects in the world. It's had a bit of a checkered history. It's been through 3 or 4 different companies. It was finally picked up by the Metals Exploration Group under Gary Powell and Peter Draper back in about 2005, Gary? That's about right. And I guess we really hit the ground in 2006. I'd like to think of it as being a fairly greenfields project at that stage. There was a bit of limited work in one end of it, but since that time we've taken the project forward to the point that we've now completed a feasibility study. I guess I should get through this. This is what I call my get out of jail free card. It literally says that I'm doing my best to tell the truth, but if I inadvertently say something that's wrong, it's not my fault. So, seeing you've all read it, I'll move on. Okay, I guess we're one of the kind of newer generations, for want of a better word, in that we took the FTAA, Financial Technical Assistance Agreement route. We planned to be 100% offshore owned in the project. We secured that in 2009. It was about a 12 to 15-month process. Status, as I indicated, work really started seriously in 2006. Since that time, we've taken it through a scoping study, a pre-feasibility study, and published our feasibility study in May 2010. We like to describe the project as development ready, It's like most projects, we're constantly running around plastering over the cracks that we know that are there, or repairing them. We're doing continuous enhancement. The project that we'll look at today is an improvement on that we produced in the study in 2010. As it stands today, I should say some time back we took a view that we could continue spending shareholders' funds by exploring, or we could try and realise the asset that we had in the ground and then from that grow the project. So we ended up with about 1.5 million ounces in resources. We've wrapped a pit around that at the moment. We have about 1 million ounces in the pit. Gives us an operation of about 10.3 years life. We'd like to think very much of that being our starter project, and we'd be looking forward to that to grow both in annual production and ultimate life. The production shown there is around 100,000 ounces a year, slightly higher in the initial years and a bit lower in the later years, as all good mines are. Allows you to catch up later on. CapEx, and I stress that this is mid-2010's CapEx. It is being refreshed now, but about $150 million. Operating costs are under 500, which looks pretty good when we're talking about $1,500 gold price. I hope it stays there. Considerable upside, as I indicated, both to extend the operation but also to produce some co-product, molybdenum. And we're very much working on the moly. We see that coming in later in the project, probably at the end of year one or into year, kind of 1.5 type of thing. And it has the potential to produce about 1 million pounds of moly as a co-product, additional cash flow of about $15 million a year. Got a lot of things going for it. The project, it's located. I should start before that. Most projects I've worked on in the past sit on geopolitical boundaries. And that's the worst place in the world to sit. This one sits in one barangay, in one municipal and one province. It's made life that much easier, and certainly the earlier workers on that took that advantage and really locked us in with our kind of social corporate responsibility working in the area, and it's been great to come along after that and to pick up with it. Access, today you can drive to it, you always have been able to. It's about 320 kilometres from Manila. That translates into somewhere between 6 and 9 hours, depends on the weather and the roads and all the rest of it. Something is pretty familiar. But we exclusively drive to it, we don't fly. I first looked at the project myself as a bit of a favour for a mate, and unfortunately he's moved on and I'm still here, so it must have been really pretty good. But I looked at it in late 2007, 2008, and I can remember walking out there and walking up the top of the hill with Gary, who's sitting over here, tailings dam, plant sites and all the rest of it. This is actually all there in front of us. It's remarkable. And I kept saying, there's got to be a crack here somewhere, we've got to find it. We haven't, as far as infrastructure and logistics are concerned. So it's 27 kilometres by road from the town, or the joint town is probably a better description of Bayambong and Solano. About half of that's cemented or sealed concrete at this stage. Then continuing to increase the concrete, it's creeping towards the site every week. The balance is well-formed national road. It's poorly maintained, as you'd expect. So for us, it's a matter of upgrading the road a little in a few areas and then maintaining it going forward. As we stand here today, there is a power line running right to the site. I might say you can see the electrons fall out the end of it. It's not exactly high quality, and we have to do something about it. But the news is good for us in that we can actually use that as an easement, upgrade the power, and tap into the national grid. Try and point out that's the national grid running down past the project. 320 kVA straight off Makati. Plenty of power, 360 megs at Makati. They're producing about 270 at the moment. And sitting at Bayambong with a bay for us is an anti-island switchyard. So if you started to design things, you started with a checklist. Many of them are there. And also an all-weather airfield at Bagabag. I was interested earlier to hear Leo saying that part of his strategy is to bring well-experienced Filipinos back to work in the industry here, and that's also very much part of our strategy. We're aligned with that. And we would hope to use the kind of well-serviced Solano Bayambong township as a base for Filipino middle and senior management placed there with their families and effectively travelling to work each day. So a lot going for it. These are calls on our website. I'm not going to go through them in great detail, but basically we have about 1.5 million ounces in resource. We have 2/3 of that in reserves, a bit over 2/3 of it in the pit. These have all been done by external experts, same people that Crazy Horse and others use here, so well known to the Philippines and to the industry. That's based on, there's about nearly 120,000 metres, 120 kilometres of drilling in there in near 1,000 holes today. Moving on to project, and I apologise for the quality of this. It hasn't transported out of the feasibility study very well, but basically it's divided up into 5 key aspects, and you'll see how this comes later for our execution strategy. But we have the mine, the open pit, which basically is very difficult to see on this, but sitting in the area in there. It sits on the side of the hill. Ultimately, most of the pit will be above the river level. You can see the Solano River running through, the Sulong River running through the project. Processing plant is divided into 2 components, one on the east side or the mine side of the river, which is the crusher, connected by conveyor to the balance of the plant on the west side of the river. Tailings storage facility will be a valley fill facility. You can see it down there in the bottom of the slide, the big orange blob. Other site infrastructure, so all of our offices and camps and various other bits, and our off-site infrastructure, the road and the power line that I referred to earlier. It's got a reasonably modest footprint for a mine of about 420 hectares. Moving on to the pit, basically conventional truck and shovel operation. A lot of it we see will be free digging, some of it will be obviously drill and blast. For us, the rock is very broken, it's quite soft. This is what we call silica undersaturated rock. There is no quartz in this thing. It is quite friable and will break up. That's the good part. That usually comes with some pretty terrible ground conditions, but the other good part is it dips very flatly through the project, so it doesn't have natural planes of weakness, and it's quite stable in its natural position. Looking to mine about 1.75 million tonnes a year of ore. That will give us our 100,000 ounces, and for that we have a strip ratio of about 5.2 to 1. So total earth movements sitting in here around 11 million tonnes per year. We're looking at a neat strategy. I think some pre-strip and the first 3 years of mining will be used to build a tailings dam wall. Once we've created that hole, we'll be tipping waste back into the pit. So we've got very short hauls, and we've become very efficient with our fleet. And so we see it today as using about 7 trucks and 2 excavators as a fleet. So very, very neat and tidy, also with a reasonably elegant environmental solution for us. Just try technology here, we'll go with it. Just trying to have a look at the stages of the mine. These are in 2-year tranches, but we basically undertake a pre-strip. We've created a ROM pad. Pre-strip, the material that's been dug out of here creates the starter wall for the tailings dam. Moving out to year 3, you can see we've actually dug a pit. This is the only part of the pit that goes below the Sulong River. All of that material has actually gone into the tailings dam wall to create its ultimate height. From then on, we start taking our waste and putting it back into the mined out pit. Well, this is pretty schematic, bear with me, it won't be that smooth, but it demonstrates it fairly clearly as we step through the mine, rehabilitate the mine back to ultimately rehabilitation. Hopefully that doesn't occur. I don't want to see that in year 11 because I want this thing to be going for another 10 or 15 years. But that's what our final mine rehabilitation plan says today.